Good morning, scholars. Welcome back to the Kemet Maasai Academy. This morning we're continuing our look at the circle, and we're focusing our attention on the circumference and the diameter, the relationship between the circumference and the diameter. Alright, so what we're going to be doing to begin with, we're going to be measuring some actual circles and measuring the diameter of these circles and seeing if we can find what the relationship is between the diameter and the circumference. Alright, so we're going to measure some actual objects. Alright, so I have a table to the left, and I'm going to be recording the measurements of a tissue roll, the circular part of the tissue roll, a sausage can, a bottle, the circular part of the bottle, a tin can, and a clock. So this is a circular clock. Alright, so for E, I'm using a measuring tape, and I'm going to be, the units on this measuring tape, should I use the inch or the centimeter? Alright, I'm going to use the centimeter section. So for the tissue roll, so remember, I'm measuring the circumference and I'm measuring the diameter. So the circumference is the distance around, all the way around the outer edge of the circle. So I'm using the circular part of the tissue roll. So let me mark where I'm starting with the chalk, using my centimeter section of the measuring tape. So I'm going all the way around. Alright, so that is 14 and a half centimeters. Alright, so the circumference 14.5 centimeters. The diameter now, I'm going to try and get my diameter, which is halfway. So I'm trying to get the widest part of the circle to measure halfway. Okay, and that is 4.5. So 4.5. It's not completely accurate because, it's hard to see the exact halfway. Alright, so the sausage can. Alright, so this is the sausage can. Let me mark off where I'm starting. So I'm starting right here. And I'm going all the way around it to get the circumference. Okay. So this is approximately 20 centimeters. Alright, now trying to get the diameter. So halfway across, and that is 6 centimeters. Alright, so now I'm going to measure the circular part of this bottle. So the opening of the bottle, the circular part of it. Alright, so I need to make sure where I'm starting, so I know where to stop. So I'm starting right here, taking my measuring tape and going all the way around the outer edge of the bottle. And that is 26 centimeters. Alright, let me try and get halfway across. So the diameter is what the distance from here to here across. So the diameter would cut the bottle into two, the circumference into two equal parts. Alright, and I'm getting, it's an estimate, but I'm getting about 7 3/4. Let me round it to that. 7.75 roughly. It's almost 8. Alright, so now it's time for the tin can. Alright, so I'm going to get the circumference. Let me mark off where I'm starting. So I'll know where to stop. All the way along the edge. The circumference is the distance around the edge, right? Okay, so that's 27, roughly 27 centimeters. And the diameter now, the distance across it, so this is about, I would say about 8.25 roughly. These are estimates. Even though I have the measuring tape, some parts of it I still have to do a little estimation. Alright, and so for the clock, so I'm going to measure along the face of the clock. Let me mark where I'm starting. So the circumference would be the distance around the face of the clock. It's a circular clock. So these are all circles. Remember, we're focusing on the circle, right? So the distance all the way around, that is 62 centimeters. And the distance across it, so from the 12 to the 6, that should be the diameter, right? So if we have the clock, from the 12 to the 6, that's halfway, it cuts the clock into 2, so that's the diameter. We could have also taken it from the 3 to the 9, and so on. Remember, there are numerous diameters in any circle. So from the 12 to the 6, that's, I would say, 19.25, 19 and a quarter roughly, 19.25. Okay, so now I'm going to divide the circumference by the diameter, because remember how mathematicians came upon this whole notion of pi. How did we come to say, well, pi is 3.14 or 22/7? How did we come by that? Remember, pi is a special number, a very special number that is used in mathematics. But how did we come about pi? Well, pi was discovered, it's a special number, one of the special numbers in math. It was discovered when mathematicians did experiments with the circle, and they realized that this number kept popping up, it kept coming up. Whenever they measured the distance around any circle, whether a big circle, a medium-sized circle, a small circle, whenever they took the measurement along the outer edge, the circumference, and they took the measurement across the middle, the diameter, and they divided the circumference by the diameter, they always got pretty much the same answer, maybe a little variation by a decimal point or so, right? But pretty much they got, and the more accurate the instruments of measurement, the more it narrowed down to 3.14. And so they were saying pi is a special relationship between the circumference and the diameter of any circle. Any circle. And you can try this at home. At home, get a number of circles. The more circles you get, the more accurate your findings will be, right? Because some of them we had to do a little estimation, a little rounding off. So it's not perfectly accurate. Our instruments and our estimation, it's not going to be absolutely accurate. But the more of the objects you use, then you will see generally the trend. So get about 10 different perfect circles. Try your very best to measure the circumference and measure the diameter, and then you're going to divide the circumference by the diameter and see what you get. So that's what we're going to do now. I'm using a calculator so that we can get more accurate readings. Right, so the circumference for the tissue roll is 14.5, and I'm dividing that by the diameter, 4.5, and I've got 3.22. The sausage can, the circumference is 20 divided by 6, and that's 3.33. The bottle, 26 divided by 7.75, 3.35. The tin can, the circumference 27 divided by 8.25, 3.27. And the clock, 62 divided by 19.25, 3.22. Now you notice, even though these measurements are not completely accurate, we had to do some rounding off, but look at the trend. We had two of them, 3.22, 3.2 something, 3.33, 3.35. So this is telling us that the relationship between the circumference and the diameter is roughly 3 point something. The circumference of any circle is roughly 3.2 something, 3.3, roughly times bigger than the circumference. The distance around, than the diameter. The distance around any circle is roughly 3.2 something, accurately 3.14. So if our instruments were more accurate and our skill in estimating was more accurate, we would come by the 3.14. But this is pretty close to demonstrate to you that there is definitely a relationship between the circumference of a circle, any circle, big, small, medium, tiny, minute, any circle, there's a special relationship between the circumference and the diameter. 3 point something, roughly 3. If we wanted to round it to a whole number, roughly 3. So then, if we know the circumference of a circle and we want the diameter, then since we know that the diameter is 3.14 or roughly 3 times the circumference, if we know the circumference and we want the diameter, we just have to divide the circumference by that special number, pi. We're going to use 3.14 or as a fraction 22/7. And likewise, if we know the diameter and we want the circle, we're just going to multiply the diameter by pi to get the circle. Since we have worked out the relationship, see the pattern, there is a distinct direct pattern. Alright, so this instruction says calculate the diameter of these circles. Now you can choose, sometimes you are told use pi as 3.14 or use pi as 22/7, depending on the numbers you're working with and whether you want your answer to be in decimal form or in fraction form. But if you are not told specifically which format, you just look at your numbers and see if they are divisible by 7 or divisible by 22, depending on which one you're working with. It's easier to work with the fraction. Or you can just go ahead and work with the decimal, the 3.14. So I'm going to interchange them, right? And we're going to work and find, so for these we're going to find the diameter. So that means we're going to be dividing these circumference, dividing them by 3.14 or 22/7. So if the circumference is 44, then the diameter is the circumference divided by pi. So 44 divided by 22/7. Remember, when we're dividing by a fraction, it's the same as multiplying by the reciprocal. So that's 44 times 7/22, and the 22 goes into 44 twice. So that's 14 meters. 14 meters, that's the circumference, that's the diameter of this circle, right? The circumference divided by pi. Alright, for here the circumference is 10 kilometers and we want the diameter. So the diameter would be 10 kilometers divided by 22 over 7, which is the same as 10 times 7 over 22. So 70 divided by 22. So 22 goes into 70. That's 66. 3 times. Remainder 4 over 22, which is 2 over 11. Okay. So 7 10 70 and 326, 326. So 3 times 22 can go into 70. If we take 66 from 70, we have 4 left back. 4 over 22 cancels to 2 over 11. So this is the diameter of this circle. 3 and 2 over 11. Alright, now here is the circumference, 9 and 7, 9. And we want the diameter. So again, the diameter would be the circumference divided by pi. I'm using the fraction form because with these numbers it's easier. But if you are told to use pi as 3.14, or if you prefer to divide by decimals, for me it's easier to divide by fractions than decimals. If you think it's easier to divide by decimals, then you would be dividing the 44 by 3.14, or the 10 by 3.14, or the 9 and 7. I find it easier to do the decimals. So 9 9 is 81, plus 7, 88, over 9, times 7 over 22, and this cancels. 4 7s, 28 over 9, and that's 3 and 1 9 meters. So that would be the diameter of these circles. So now we're asked to calculate the circumference. So remember, the circumference is the diameter times pi. The diameter times pi. So if the diameter is 14, then the circumference would be 14 times 22 over 7. 7 cancels into 14 2 times, and 2 times 22, that's 44 millimeters. The circumference, the diameter is 20, so let's use the 3.14. So the circumference would be the 3.14 times 20. 2 4 is 8, 2 1s 2, and 2 3 is 6. So that would be 62, put in our decimal point, 62.8 centimeters. Okay, so if the diameter is 20, then the circumference is 20 times pi, using pi as 3.14. So the circumference would be 62.8 centimeters. If the diameter is 11, so the circumference would be the diameter times pi, or 11 2s 22, 11 2s 22, plus 2 24. 7 into 24 3 times, remainder 3, and 7 into 32 4 times, remainder 4 over 7. Alright, so let's check that. So 11 2s 22, 11 2s 22 plus 2 24, and we're dividing it by the 7. 7 into 24 3 times, remainder 3. 7 into 32 4 times, remainder 4 over 7. Alright, so because we have realized that there is a special relationship between the diameter and the circumference of all circles, any circle, and you can do this for yourself at home, try and get it as accurate as you can. Divide the circumference by the diameter and you will see a pattern. The more accurate you are with the measurements, the closer it will be to 3.14. So knowing this relationship then, since we know that the circumference is roughly 3.14 times the diameter, if we are given the diameter, we just multiply it by, if we are given the diameter, we multiply it by 3.14 to find the circumference. And if we are given the circumference and we want the diameter, we divide the circumference by 3.14 or 22/7 to get the diameter. So which one you use is really up to you, which one you prefer to work with, the decimal form or the fraction form, or if you are the question specifies that you should use pi as 3.14 or use pi as 22/7, then you know you have to do that, right? But you will get the same answer though. The answer will be the same. Remember, it's the same thing, it's just a different format of expressing it. The 3.14 in the decimal form and the 22/7 in fraction form. Alright, so remember to look out for the other videos on the circle. There was an introductory video on the circle, the parts of the circle and what they are, the terms used, and look out for the video on the relationship between the diameter and the radius, as well as calculating the circumference given the radius or given more practice with given the diameter, and finding the area of the circle. So look out for all those videos, and if you have been helped by this video, just drop a line of appreciation to say thank you, miss, in the comments, and share the video so other students can benefit from the information. If you haven't subscribed, please do so, and let me know if you want me to do a video on any topic that you need help on. Just let me know. So scholars, I'll see you in the next videos. Take care.